Hi and welcome to the Magic of Mathematics with Mrs. Arnold Harsley. Today we're going to look at Basic Algebra Part 3, Multiplying Algebraic Terms. We're going to look at what does it mean to simplify terms, what are the rules for multiplying terms, and what is the difference between adding and multiplying terms. So simplifying, when you regroup terms into a simpler form, it is known as simplifying. Simplifying will result in fewer terms in an algebraic expression. So a quick example of this is if we have 4a multiplied by 3b, you've got one term there and you've got one term there. So that's two terms altogether. If I multiply them together, that will be 12ab, and we'll go through later how to actually do that. And we've reduced those two terms to one term. So that's what is meant by simplifying. We've multiplied them together, two terms together, to produce one term. So it's being shown in its simplest form. So what are the rules for multiplying algebraic terms? When a term is made up of a number and a variable or variables, there is a hidden multiplication sign in between each of these. So if we just have a look at the examples, 4a means there is a hidden multiplication sign in between the 4 and the a. So 4a actually means 4 multiplied by a. It means there's 4 lots of a. So 6b would be 6 multiplied by b. 14ab would be 14 multiplied by a multiplied by b. And 12bca would be 12 multiplied by b multiplied by c multiplied by a. Rule number 2, the best way to simplify terms that are being multiplied together is to expand them first. And that means you need to write them out again and include all of those hidden multiplication signs before you simplify. So if we just have a look at this example, we've got 4a multiplied by 6b. There'll be a hidden multiplication sign in there between 4 and a, and a hidden multiplication sign in there. To expand it, we would write 4 multiplied by a, and then this multiplication sign, and 6, we just erase that, and 6 multiplied by b. My 6's and my b's look very similar, so I should have picked a better number. So 4 multiplied by a multiplied by 6 multiplied by b. So rule number 3, when you expand any variable that has a power, remember the rule of writing the base number first and then multiplying the base number by itself the same number of times as the power indicates. So what does that mean? Let's look at the first example. We have 4 to the power of 2, or 4 squared. 4 is the base number. So we write the base number and we multiply that base number by itself this many times. So it's telling us to multiply 4 by itself 2 times. So that would be 4 multiplied by 4. In the example of a to the power of 2, a is the base number. So you would write a as your base number and multiply by itself this many times. So that would be a multiplied by a. And in the last example, you've got b to the power of 3. b is the base number, and we're multiplying b by itself 3 times because that's what the power is telling us to do. So that would be b multiplied by b multiplied by b. Okay, so now let's work through some examples. Example 1 is 6c multiplied by 9c. So we're going to expand it first and write it with all of those hidden multiplication signs in. So we've got 6 multiplied by c, because that is that hidden one in there. Multiply again, which is that one there. 9 multiplied by c, where this multiplication sign is the one hidden in there. So we've just expanded it so far. Now we need to take it a step further and multiply them. So we've got 6 multiplied by 9. So always multiply any numbers first. So 6 multiplied by 9 is 54. Then we've got c multiplied by c, and I would refer you back to rule 3. c multiplied by c. C is the base number, and it's being multiplied by itself 2 times, so that would be c squared, or c to the power of 2. So 6c multiplied by 9c is 54c squared. Moving on to the next example, we've got 10a multiplied by 5b, so I'll expand it first. 10 multiplied by a, multiplied by 5, multiplied by b. Again, we're going to multiply the numbers together first. 10 multiplied by 5 is 50. And then we've got multiplied by a and multiplied by b. We can't simplify that any further, so the only thing left to do is to rewrite it and remove those multiplication signs, so it becomes 50ab. In the next example, we've got 8x squared multiplied by 3x. We're going to expand it again, so it's 8 multiplied by x squared. So x squared is x multiplied by x. Then this multiplication sign, and then 3 multiplied by x. There, that's better. All right, so we multiply the numbers first. 8 times 3, or 3 times 8, is 24. And then we've got x multiplied by x multiplied by x. So x is being multiplied by itself 3 times. So we write x as the base number to the power of 3. Okay, so the last example has got negative numbers in it. We've got negative 5y squared x multiplied by negative 6 x squared y. So just a little quick refresher on multiplying positive and negative numbers. The little rule chart up here that I'm going to do will tell you that if the two numbers you're multiplying together are both positive, then the answer will be positive. If both numbers are negative, the answer will be positive. If you're multiplying a positive and a negative, or a negative and a positive, then the answer will be negative. A really quick way to remember that is, if the signs are the same, the answer is positive. If the signs are different, the answer is negative. Okay, so the first thing we're going to do is expand this. So we've got negative 5 multiplied by y squared. So that would be y multiplied by y. And then this x here multiplied by x. And then multiplied by negative 6 x squared this time. So x times x times x. And this y here multiplied by y. So the first thing we'll do is multiply negative 5 by negative 6. Now the rules for multiplying the numbers also will tell you that you ignore those signs. So pretend they're not there and just multiply the numbers together first. So that means you're multiplying 5 by 6 or 6 by 5, which is 30. Once you've multiplied the numbers together, then you look at the two signs. In this case, they're both negative. So this is the one in the chart you'll need to look at, and it will tell you that that 30 in the answer needs to be a positive 30. So we don't need to write the positive sign. 30 on its own is already telling us that it's positive. Okay, so algebraic expressions, write them in alphabetical order where possible. So I'm going to look at the x's next. We've got 1, 2, 3. So we've got x being multiplied by itself 3 times. So that would be x to the power of 3. And y is also being multiplied by itself 3 times. So that would be y to the power of 3. So now we'll have a quick look at what the difference is between adding and multiplying the same pairs of terms. So in the first column here, we've got to add x and x. And again, I'll refer you back to Basic Algebra Part 1, where you find that if you have a pronumeral variable on its own, there is an invisible 1 next to it. So x on its own means 1x. A on its own means 1a. So there is a 1 here and a 1 here. So what you do when you add is you add those two coefficients to make 2, and you just collect the like term of x. It's like having one xylophone and then you get given another xylophone. How many do you have altogether? You've got 2 xylophones. And when you multiply, x multiplied by x is where you take the base number of x. It's being multiplied by itself 2 times, so it would be x to the power of 2. And that is described in Rule 3 in this YouTube clip. So when you add x and x, you get 2x. When you multiply x and x, you get x squared. Moving to the next example, very similar. You've got 6x, add 3x. Now you've got 6 xylophones, and you're going to buy another 3 xylophones. So how many xylophones do you have altogether? You're going to have 9 xylophones. You add the 6 and the 3 to get 9, and then you just collect the x. For 6x multiplied by 3x, you expand it. So 6 multiplied by x, multiplied by 3, multiplied by x. We multiply the numbers first of 6 and 3. 6 times 3 is 18. And then x multiplied by x is x squared, just as it shows us here. The next example is an important one. You've got 10a, add 5b. So you've gone to the shops and you've bought 10 apples and 5 bananas. Can they be added together? No, they can't, because you can't have 15 banapples. You can't add unlike terms together. So that stays as 10a, add 5b, because it cannot be simplified any further than that. However, when you multiply 10a with 5b, first of all, let's expand it. So we've got 10 multiplied by a, multiplied by 5, multiplied by b. Multiply the 2 numbers first. So 10 by 5 is 50. Then you've got multiplied by a and multiplied by b. And then the only thing left to do is to remove those multiplication signs to give you 50ab. So when you're adding or subtracting unlike terms, you cannot add them together, but they can be multiplied together. That's another big difference between adding and multiplying terms that a lot of students get confused with. So the final example, we have got 4x squared, and we're going to add to that 9x squared. So you can see we've got an x squared and an x squared. So they are like terms, they are the same term. So all we have to do is add the coefficients. So add 4 and 9 to give you 13. And then just collect that like term of x squared. If we multiply 4x squared by 9x squared, let's expand it first. You've got 4 multiplied by x squared, which is x multiplied by x, then this multiplication sign, then 9 multiplied by this x squared, which is x multiplied by x. So 4 multiplied by 9 is 36. Then you've got 1, 2, 3, 4 x's. X is being multiplied by itself 4 times. So we write x to the power of 4. So today we looked at what is meant by simplifying. We expanded terms to simplify. We went through examples of multiplying algebraic terms and the differences between adding and multiplying terms. Thank you for watching. If you found my clip useful, please subscribe to my channel, The Magic of Mathematics with Mrs. Arnold Harsley. Until next time, see ya.